Okay, good afternoon to everyone. All of you can able to hear my voice?
Yes, sir.
Yeah, நிறைய பேர் joined. What happened? Only 34 members are joined. What about others?
Last class test exam, sir.
சரிங்கண்ணா அதுக்கு இதுக்கு என்ன இருக்கு? டெஸ்ட்டுக்கு இதுக்கு என்ன இருக்கு? This is a final advance. Okay. Okay. The last class we have seen, okay, what is the sequential circuit? The sequential circuit is nothing but the combinational circuit plus memory element. We call it as a sequential circuit. The sequential circuit is divided into two categories. One is called as a synchronous sequential circuit. Another one is called as a asynchronous sequential circuit. Synchronous in the sense, what is the synchronous sequential circuit in the sense? The clock is it's going to control entire sequential circuit. So it is called as a synchronous sequential circuit. And the next we introduced what is a memory element, how we are going to implement that memory element in the sequential circuit. We can implement the memory concept using two ways. One is latch, another one is a flip-flop. Okay. We are last class we are initiate with the SR flip-flop. Okay, I'm going to continue with the SR flip-flop. Okay. This is a circuit diagram for SR flip-flop. SR latch. The SR latch implementation using NOR gate. Okay, this is a circuit diagram for SR latch. Okay, this is a memory element. Okay, one input is S, another input is R. Okay, so it's going to generate the output is called as a Q. The Q otherwise is called as a set. The another output is called as a Q dash. The Q dash otherwise called as a reset. Okay, the Q dash otherwise called as a reset. Okay, so for here what happened? We are taking the two variable. One is called as two variable, namely called SR two variable. Okay, the two variable means how many number of input combinations are available. The two variable means how many input combinations are available means 4 input combinations such as 0 0 0 1 1 0 1 1. Okay, so now what I'm going to do, I'm taking each and every input and then I'm going to check that what is the behavior of that memory element. Okay, so now what I'm going to do, I'm going to take each and every memory element and then I'm going to check that what is the behavior of the particular memory element. Here what I'm going to do, instead of taking the input as a sequential order, what I'm going to do, I'm going to take it as a random. Sir, why I'm taking it as a random in the sense, in your textbook, they take an input like that. Okay, this is the textbook. Here what happened, they will take the input in random order. So in order to understand the book concept, what I'm going to do, I'm also what I'm going to do, I'm going to take the input in random order. Okay, so first what I'm going to do, first what is the truth table for this is a NOR gate. First of all, you should know what is the behavior of NOR gate. So now what is this is a truth table. A, B, they finally going to produce output. If the both inputs are okay, whenever the both inputs are 0, then only what happen, the output equal to 1. The rest of the cases what happen, the output equal to 0. Okay, this is a truth table for AND gate. Sorry, this is a truth table for NOR gate. Okay. Okay. First, what I'm going to do, I am taking input as my input is first case 1. My input combination is 0 1. Okay, S equal to
Sir,
0.
screen is not visible, sir.
Oh, not visible. Now it's okay, ma? Now it's okay? Hello?
Yes, sir.
Okay. So I am taking input as 0, 1. Okay, here two variables are available. One is S, another one is R. If two variables means how many number of input combinations are available? 0, 0, 0, 1. Another one is 1, 0. Another one is a 1. Four combinations are available. Here, what I'm going to do, I'm instead of taking a sequential order, what I'm going to do, I am taking it as a random order. So why I'm taking it as a random order in the sense, in your textbooks, they given like that. First, they taken 1, 0, and then 0, 0, 0, 1, again 0, 0, 1, 0. So similarly, what I'm going to do, I'm going to take it. Okay, the initial input is a 0, 0. Now I'm going to check that what is the behavior of SR flip flop. Okay, so this is a circuit diagram. Okay, this is a circuit diagram for SR flip flop. Okay. So already said the sequential circuit, how it's going to make a decision in the sense the current input as well as the previous output which is available in the memory, previous output. So based on that, what happen, it's going to take the decision. Okay. So now I am taking input as S equal to 0 and then R equal to 1. Okay. Initially, sir, first now only I am going to start the circuit, sir. In the sense, what is the values available in the memory element in the sense 0. For example, this is a circuit diagram for sequential circuit, the combination circuit. Okay, and then here memory elements are available. This is a memory element. This memory element is feedback for that combination circuit. Okay, am I correct? Sir, now only I am going to start the operation, sir. What is the value, initial value is available in the memory element in the sense, initial value equal to 0. Okay, so initial value equal to 0. Okay, so from this NOR gate observation, what do you understand from this? If any one of the input value equal to 1, equal to 1, definitely the output value equal to 0. From this information, I am going to infer from this table. Okay. If you look at that table, one of the input is 1. Sorry, one of the input is 1. So definitely, irrespective of another input, definitely what happens? It will generate this. It will generate the output equal to 0. Okay. So this is a feedback for here. Okay, this is a feedback for here. So look at the NOR truth table. If the both inputs are 0, what happens? If both inputs are 0, what happens? It's going to produce output equal to 1. So from this, what I'm going to do, I'm going to write the truth table for SR flip flop. So what is my input? My input is S. One input is S. Okay. Another input is Q. Sorry, R. Okay. Already I said it associated with the two. It going to generate the two output. One is called as a Q. Another one is called as a Q bar. If the both input, suppose I am taking input is 1, 0. I'm taking this 1, 0. What it going to does? So what it going to does in the sense, the output equal to 0. Sorry, sorry. 0, 1, sorry. 0, 1. What it going to does? The Q equal to 0 and then Q bar equal to 1. Okay. So it is okay for you? It is okay for you?
Yes, sir.
Okay. So next what I am going to do, next input combination is a 0, 0. So now next I am taking test input as 0, 0. Now I am going to check what is the behavior of SR flip flop. So S equal to 0 and then Q R equal to 0. Okay. Sir, previously what we have did is one of the input equal to 1. So based on the truth table, what happened? I will generate the output. Here both the inputs are 0. So in the cases, okay. So what we are going to do? Here 0, here 0. We are unable to predict any one of the input. I am correct. So such a cases, what you are going to do? The previous output value is the input for any one of the gate. You can take any order. So now what I'm going to do, I'm going to take this order. Okay, Here, sir, here what happened? Previously, what happened? Any one of the input equal to 1. So, if it is there, I can easily predict the behavior of the gate. Okay. Here, both of the inputs are 0. Because of that, I am unable to predict the behavior of the NOR gate. So, such cases, what you are going to do? You consider the previous output as an input. Okay, what is the previous output? The previous output equal to 0. This is the input for this NOR gate. This is the input for this NOR gate. S equal to 0, and then here also 0. Okay, obviously what happened? You look at the NOR truth table, 0, 0, 0. What happened? Output equal to 1. So here output equal to 1. Okay, this is the input for here. Output equal to 1. This is the input for here. So what happens? 0, 1, 0, 1. What is the output? 0. So whenever I am going to provide s equal to 0 or equal to 0, so what happened? It's similar to previous stage. It's similar to previous stage. Okay, it's similar to previous stage. So it's okay for you? It is okay for you? Hello? Okay. The next I am taking another input combination. What is the next input combination in the sense? I am taking 1 0 s equal to 1 or equal to 0. Okay, third case s equal to 1 or equal to 0. Third case. Okay, s equal to 1 is equal to 1 or equal to 0 or equal to 0. Now what I'm going to do, I'm going to predict the behavior of the circuit. Okay. Sir, here, if we consider as yes is equal to 1. So from this, what happened? I can easily predict the output of that NOR gate, because if any one of the input equal to 1, what happened? The output value equal to 0. So simply what I'm going to do, I'm going to write it as a 0. Okay. Okay, 0. This is the input here. This is the input here. So if the here r equal to 0, the next input also 0. What happens? The output equal to 1. 0, 0, 0, 0, 0 in the sense the output value equal to 1. Okay. So whenever s equal to 1 or equal to 0 in the sense the q value equal to 1, q bar value equal to 0. Okay, similarly for next case. What is the next case? I'm taking for next case 4. So my input combination is again 0 0. My input combination is 0 0. Okay, my input combination is 0 0. Okay, one of the input is 0 0. Okay, r equal to 0 and then s equal to 0. S equal to 0. I'm going to check what is the behavior of the circuit. Okay. Okay. Here, how do you predict the behavior of the circuits? Here, both of the inputs are 0. Okay, sir. So such cases, what you are going to do? Okay, you can refer previous stage output. Okay, so for example, what I'm going to do, I'm going to take previous stage output. Here, what is the output of previous stage? 1. So 0 1. What is the behavior? 0 1 in the sense 0. Okay, so this is a feedback for this NOR gate. This is a feedback for this NOR gate. What is the 0 0? Both the inputs are 0 0 in the sense output value equal to 1. So what happened? So it will retain the previous stage. It will retain the previous stage. Okay, this is a retain the previous stage. The next case, so both the inputs are 1. So what happened? For example, I'm taking the next case equal to 5. So what I'm going to do, I'm going to determine the behavior of this latch or memory element. Okay, latch or memory element. So s equal to 1 and then r equal to 1. Okay, this is called as a q bar, this is called as a q. So look at that input combination. If the one of the input is 1, so definitely we can conclude that definitely the irrespective of another input, definitely what happens that NOR gate is generate the output equal to 0. Okay, the NOR gate definitely what happens? It will generate the output equal to 0. sorry, 0. One. Okay, 0 0. So what happened? The SY equal to 0. 1. Okay, listen. Okay, S equal to 1 or R equal to 1. Definitely what happens, sir? This is a 0. Okay, this is also 0. Okay, this is also 0. Then Q dash also 0. Sir, if you look at that diagram, so what they given, if one of the input equal to 0 in this, then definitely another input equal to 1. Okay, so one of the input is 0 in the sense, definitely another input equal to 1. If suppose the input another, suppose the first input is 1, means definitely second input equal to 0. Such a way that it should be appear. That's why they can be denoted like the q bar. Here it is not satisfied that condition. That's why that state people called as a forbidden state. That stage people called as, it is called as a forbidden stage. Okay, so what is the meaning of forbidden stage in the sense? So while you are going to find out the characteristics of particular SR latches, okay, you are not going to consider that input combination. So that is the meaning of forbidden stage. Okay, how they the SR latches, okay, how they can be represented means make use of like that A S or Q bar. Okay, if it is provided like that, what is the meaning is that is called as a SR latch. Okay, that is a diagrammatic specification of SR latch. So do you have any queries? Do you have any queries? Hello. Do you have any queries? Hello.
No, sir.
Okay, there is a behavior of SR latch using NOR gate. Next, what I'm going to do, the SR latch implementation using NAND gate. Okay, so what do you understand from this in the sense? So okay, I'm going to summarize SR latch. Okay, SR latch using NOR gate. The NOR gate means, okay. So two input and then it's going to produce a two output. One is called as a Q dash. Okay, Q dash. Okay, Q dash. If 0 1, the how we are going to provide input combination 0 1 in the sense the output equal to 0 1. If next 0 0 in the sense the output equal to 0 1. What is the meaning is it is retaining the previous stage. It's retaining previous stage. Next, what I'm going to do, I'm going to change one of the input combination. If it does, what happen? It's going to produce output equal to 1 0. Next 0 0 in the sense it's going to produce output as previous stage as output. Previous stage as output. Previous stage as output. The next, my input combination is 1 1 in the sense the output equal to 0. Okay, so this is that state we call it as a forbidden state. Forbidden state. What is the meaning of forbidden in the sense? While you are going to find out the behavior of the particular SR latch gate, okay, you are not considered for one input combination. You are not considered one input combination. That is the meaning of forbidden state. Okay, what do you understand from this in the sense? Sir, here which one is we call it as a memory? This is called as a, already I said Q, otherwise Q is called as a set, and then Q dash otherwise called as a reset. So here, what do you understand from this in the sense? The look at the input combination. Whenever the S value equal to 1, the Q value equal to 1. Okay. Whenever the S value equal to 1, the Q value equal to 0. Suppose the S value equal to 0, what happened? The Q value equal to 0. So what is the meaning of set in the sense? Okay, this is a memory element. The set is acting as a memory element. Okay, so S value equal to 0 in the sense the memory containing values are 0. If S value equal to 1 in the sense the memory containing element is 1. Okay, so it will store one bit of information. Okay, that is a final observation of SR latch. It is okay for you? SR latch using NOR gate implementation. It is okay?
Okay, sir.
Okay. So next, what I'm going to do, see, I'm taking for SR latch, but instead of implementing the NOR gate, what happened? I am taking for NAND gate. Okay, SR latch implementation using NAND gate. Okay. Okay. First of all, we should know that what is the behavior of NAND gate. What is the NAND gate behavior? A, B, this is a F. So my input combination is 0, 0, 0, 1, 1, 0, 1, 1. Okay, what is the behavior? If any one of the input, first three input combination is output equal to 0, the last input, okay, whenever the input combination 1, 1 in the sense, the output value equal to 0. Okay, this is the behavior of NAND gate. So, okay, next I'm going to draw the circuit diagram for SR latch using NAND gate. Okay, this is a NAND gate. Okay. Okay, this is a Q, this is a Q dash. Okay, you want to keep in one more thing. Suppose SR latch implementation using NOR gate in the sense how it should be appear. The R is there and then S is there. So R output is called as Q dash and then S output is called as a Q. Okay. Suppose suppose I'm going to implement SR latch using NAND gate in the sense S output is a Q and then R output is a Q bar. Okay, you want to that information keep in your mind. Okay, such a way that one smaller difference is there. Okay, previously we have seen SR latch using NAND gate, SR latch implementation using NOR gate. Such cases, how it should be appear in the sense S output is called as a Q and then S output is called as a Q bar and R output is called as a Q. Whereas SR latch implementation using NAND gate in the sense S output equal to Q, then R output equal to Q dash. That information you keep in your mind. Okay, so now I'm going to check that. This is a two variable function S and S. Okay, S and R. How many input combinations are there? 0, 0, 0, 1, 1, 0, and then 1. Okay. I'm going to take each input combination and then I'm going to check that what is the behavior of that circuit. Okay, what is the behavior of that circuit? So my initial input is 0, 1. Okay. Okay. So S equal to 0 and then R equal to 1. Okay. So now I'm going to check that what is the behavior of the circuit. Okay. So what information you are going to infer from the NAND gate? If any one of the input combination is 1, if any one of the input combination is 1, definitely, if any one of the input combination is a 0, definitely the output value equal to 1. That information I am going to infer from this NAND gate. Okay. Here what happens, sir? Here the one of the input is 1. I am correct. One of the input is a 0. If one of the input is a 0 in the sense that definitely irrespective of another input, definitely what happens? The output value equal to 1. Okay, this is the input for this one. Okay, what happens, sir? So 1 1. Look at the table. What is a q bar? Q bar equal to 0. If the both inputs are 1 1 in the sense, okay, both inputs are 0 1. Okay, that's a 0 1 1 in the sense. What is the output? 0 1. 1 0. Okay. Okay. So from this, what happened? I'm going to draw the truth table. What is the input value? S R Q Q dash. What is my input? 0 1. Okay, 0 1. What is the output? The Q equal to 1, Q dash equal to 0. Okay. So next, I'm taking for next input combination. What is the next input combination? And take it as input combination as a 1 s equal to 1. Okay, is equal to 1 or equal to 1. And then I'm going to check what is the behavior of SR circuit, SR latch. Okay, okay, this is the previous output. Okay, sir, if any one of the input combination is a 0 in the sense, I can easily predict the behavior of the gate, but here both inputs are 1. Such cases, what happened in the sense, you take the previous stage output as an input. Okay, you can work it out any order. Here I am going to work it out here to there. So I am taking the here what happened, the previous stage output equal to 1. Okay, this is the input for here. Okay, both the inputs are 1. What happened? The output equal to 0. Okay, this is a feedback for here. So 1 0. 1 0 in the sense, what is the output? Q1. So what do you understand in the sense, if the both the inputs are 1 in the sense, it will retain the previous stage. Okay, it is okay for you? It is okay for you?
Yes, sir.
Okay. So next I am taking in next another input combination 1 0 1 0 1 0. Okay. I'm going to check that what is the behavior of the circuit. Okay. Here the one of the input is 0 here. Definitely what happened? You can predict the behavior of the particular NAND gate. Okay, you can predict the behavior of the particular NAND gate. Definitely what happened? The output equal to 1. Okay, this is a input for this gate. Both the inputs are 1. If 1 1 in the sense, what happened? 0 q and equal to 0. 0 and 1. Okay. Next step. I'm taking 1 1. Okay, 1 1. Okay. So same cases. If one of the input is 0 in the sense, I can easily predict the output. But here the both the inputs are the 1 1. Both the inputs are 1 1. That cases, how do you predict the behavior? So such cases, what happen? You take the previous stage output as an input for current stage and work it out this order. So previous stage output equal to 0 0 1. Sorry, 1 0 1 0 in the sense output equal to 1. Okay, this is a feedback for here s equal to 1, here 1, what happened? 1 1 in the sense output equal to 0. So my input is 1 1. After 1 0 followed by 1 1, what happened? My output is 0 1. So again, what happened? It will retain same stage. Okay. So next, what I'm going to do? I'm taking input as okay 0 0 0 0. Here 0, here also 0. Okay. So already you know that if any one of the input is 0 0 in the sense, what happened? Definitely output equal to 1. Here 1, here 1. Okay. It is a countertext to that SR latch using NAND gate because one of the output, the Q1 Q bar complement with each other. Q1 Q bar complement with each other, complement with each other. But the output, how it should be appear? So what is a hidden meaning is, suppose the q value equal to 0 in the sense, definitely q bar value equal to 1. That is a hidden meaning. Suppose that q value equal to 1 in the sense, q bar value definitely equal to 0. Okay, such a way that the output should be produced. But whereas in this case, what happened? S equal to 0 and R equal to 0, the both the output value equal to what happened? 1, 1. Okay, what is the meaning is, this state we call it as forbidden state. Okay, what is the meaning of forbidden state in the sense? Like that input combination, you should not allow, otherwise you should not encourage for SR latch using NAND gate. You should not allow that input combination. That is called as a forbidden state. Sir, நீங்க கேட்கலாம், why sir you are taking input as randomly in the sense? Sir, initially how in your book they work it out, based on that what happen, I will take it as a input combination. In your book they work it out like that. That's why I'm taking it as a input combination. It's like that. Okay. So from this, what you are going to infer in the sense? Okay. So now what happened? I'm going to compare. Okay. So this SR latch using NAND gate, otherwise called as an S bar, otherwise called as an S bar or bar latch. I will tell you why it is called as a S bar or bar latch. So in order to understand that name, what happened? I'm going to consider both implementation. So what is the truth table for SR implementation using NOR gate, and then SR implementation using NAND gate. Okay, what is the truth table? So SR, what is the two output? Q and Q bar. So what is the input combination? 0 1, 0 0, and then 1 0 0 0 1 1. So what is the output? 0 1 0 1 1 0 1 0 1. This is the output. Similarly, SR implementation using NAND gate, in the sense, what is the output? SR Q bar. Okay. What is the input combination? 0 1 1 1. Next 1 0 1 1. Last stage is 0 0. So what is the output combination? 1 0 1 0 0 1 0 1 1 1. Okay, this state is called as a forbidden stage for NOR gate implementation. This is a forbidden state for NAND gate implementation. This is for as a forbidden state. This input combination they call as a forbidden state. So what information you are going to infer from this in the sense? So first you look at SR using NAND gate. So whenever the S value equal to 0, definitely the Q set value equal to 0. Suppose S value equal to 1 in the sense, Q value equal to 1. That's why it's called as a SR latch. So set SR value, that is output for Q. That's why it's called as a SR latch. Whereas if we consider SR using NAND gate, in the sense, whenever the S value equal to 0, the Q value equal to, it is just opposite, 1. If S value equal to 1 in the sense, the Q value equal to 0. That's why it is called as a S bar or bar latch. Okay, S bar or bar latch. Okay, how it can be represented, the diagrammatic format in the sense. Okay, here one bubble is there. Yes, here also one bubble is there. This is called as a R. Okay, this is output Q bar. Okay, this is called as a SR or bar latch. Okay, how? Okay, whereas in the SR latch, how should we appear in the sense? It should be appear without that bubbles. This is called as a Q. This is called as a Q bar. Okay, this is called as a SR latch. Okay, it's okay for you? Hello.
Yes, sir.
Okay, do you have any queries regarding this? Do you have any queries? Do you have any queries?
No, sir.
Okay. Okay, thank you so much. We will see next class. Okay, if you had any queries to be stay on online, otherwise you can wind up the session.